Hello and welcome to this episode of Beyond the README. Today we're going to be talking about error handling in Ansible. Now, error handling is a crucial aspect of really any software or systems project, but it tends to go overlooked in the ways we automate our systems. It's very easy to assume that your automation platform or your playbooks will always run successfully, and as a result, you might not pay attention to handling any errors that might crop up, which can leave your systems in unexpected states. So in this episode, we're going to talk about the different ways you can handle errors in Ansible. Now, if you'd like to follow along, I'm using a fairly simple environment here. I'll have my Ansible control machine on my laptop, and I'll run Ansible against a collection of 4 web servers. These are just Linux machines running Ubuntu server. I happen to have them set up in KVM, but you can have them running anywhere you'd like. So before we jump over to the keyboard, let's consider the 3 things that I think you need to consider when it comes to failure and errors. The first is, how do we define failure? What does it mean when we say failure in the context of our automation? Next, we have to consider how we handle failure at the host level. So a play is typically composed of multiple hosts. How are we going to handle failure for that one individual host? And then finally, how do we handle failures at the play level? Does a host failing a particular task result in the failure of the entire play for all hosts, or do we adopt a different strategy? So let's go ahead and get started. I have here a pretty simple inventory file. You'll see I have my 4 web servers located inside of this inventory. We're going to start with just working on the one web server for now, and then we'll build up to using the other ones over the course of the video. So I'm going to start with defining a very basic playbook. Now in this environment, we're going to imagine that we have some kind of application installed on these servers, and its configuration lives in /var/myapp. You can see that directory is currently empty, and that's the same on all of the web servers. So first, let's discuss how we define failure for an individual task. So let me go ahead and write a new task here that checks for the existence of a particular file on the file system of this web server. So what I'm going to do here is use Ansible's built-in file module to check to see if a file exists. In this case, a file at /var/myapp/change is disabled. And the purpose of this file is to manually disable any changes against that system. This is fairly common if you're troubleshooting or debugging a system to have your automation check for the existence of some kind of file that basically acts as a lock. And if that file is found, no changes will be made via the automated processes. In this case, the Ansible file module will fail the task if this file doesn't exist, and we can confirm that. And you can see that task fails. But in this case, we actually want that task to succeed when the file is absent. So how can we do that? Ansible allows you to define failure for a particular task. So if you look at the official documentation, Ansible explains that you can define failure using the failed when parameter on a particular task. And to do that, we can inspect the result of that task. So there are a few ways that you can understand what the result object holds for a particular task, but I'm going to use the Ansible debugger in this case just to see what this task looks like when it fails. So by setting my Ansible strategy to debug and rerunning my playbook, I'll drop into a debug console once the task fails. And I'm going to print out the result object here. Now the Ansible debugger is fairly unintuitive, so I'm not going to take the time to explain that in this episode. But basically what I'm doing here is printing out the result object from that task, and you can see that the state is set to absent. So in this case, the task will fail when the state is absent by default. We want to control that and change it to fail only when the state isn't absent. So if that file exists, we want this task to fail and not perform any additional changes against this system. We can do that by registering the result of this task to a variable, and then using that failed when keyword to inspect that variable. So I'll register this result object to a variable, and then I'll set my failed when keyword to fail when the state is not absent. So now this task should only fail if that file exists. So let's go ahead and give that a shot. And we can see now that that file didn't exist, so the task was successful. Now if I come over to that web server and I create that file, we should see the task fail. And sure enough, now the task fails because the state of that file is not equal to absent. You can see that the state is currently set to file. So using the failed when keyword allows you to define failure for a particular task, which is helpful in all kinds of different scenarios. So let me go ahead and remove that file so we're not failing the playbook anymore. and we'll look at another way that we can define failure for a task unrelated to the status that it returns. So it's pretty common to need to set a timeout for a particular operation. You might want to consider a task to have failed if it takes longer than a certain amount of time. And this is helpful for software that's not very good about timing out on its own. For example, you might call an operation or run a command that comes with your software, and if it runs for longer than a couple of seconds, you know that it's going to fail eventually, so you might want to just immediately fail that task so that your playbook can handle it accordingly or fail and move on. So you can set a timeout on a task as well, and in this case, we're going to use the sleep command just to simulate what this might look like. So I'm going to sleep for 10 seconds, and then I'm going to set the timeout at the task level to be equal to 5 seconds. Now when Ansible encounters this task, it will run the sleep command, which will wait for 10 seconds and block, but at the Ansible level, that timeout is equal to 5, so it will fail the task after 5 seconds if it hasn't returned. So let's go ahead and give this a try. We can see we've hit that timeout task and it's currently running. After 5 seconds, the task fails, and you can see that the Ansible action failed to execute in the expected time frame of 5 seconds. So timeouts are really important, and I recommend you use them where appropriate. I can't tell you the number of times I've run into a race condition or some other kind of issue with a piece of software that results in a weird state where it just runs forever, and then Ansible will hang as a result. If you think there's any potential of that, I recommend adding timeouts around your tasks, unless of course you can fix the underlying software itself. So now we've seen how we can handle failure and errors at the task level. Now let's discuss how we can handle failure and errors for tasks on a particular host at the host level. So I'm going to create a new playbook now that we're going to run. So now let's imagine for our fictional app that we want to make sure the health check is enabled for that app. And let's assume there's a simple monitoring configuration file for that application. If that monitoring configuration exists, we want to ensure there's some configuration value set that enables a health check. If it doesn't exist, we just might not care and we want to move on. So let's start with the ability to actually edit that file. So here I'm adding a task that uses Ansible's block-in file module to ensure the enable monitoring block exists in a file called monitoringconfig.ini in the my app directory. Now if this file doesn't exist, the task is going to fail, and we can confirm that. If we look in the web server, there's no monitoring config currently. So let's go ahead and run this playbook to see what happens when that file doesn't exist. As you can see, the task fails because the file doesn't exist. So let's go ahead and create this monitoring config file, which should enable the task to succeed. Now that I've created that file, I can rerun the task, and now it should be successful. Sure enough, we can see that the task was successful, and now if I look at that monitoring config file, it has that Ansible managed block inside of it. But what if I don't really care if this file exists? What if I only want to enable monitoring on a host if this file already exists? Maybe I'm giving my end user some ability to create that file or leave it absent. In that case, what I actually want to do is ignore an error for this particular task. And instead of having it fail my play for that host, I actually want my play to just continue as normal. So let me go ahead and remove this file again. We can use the ignore errors parameter to ignore any errors that might crop up when a task is running. Now if this file doesn't exist, Ansible won't care and it will just continue on with the play. Now we can see that Ansible hit that task, it failed, but you notice that it said it was ignoring it, and the play continued on like normal. And if we look at the exit status for the Ansible playbook command, it exited with a 0 return code, so the play was still considered successful. Now let's consider how we can actually deal with failures at the host level. Ansible provides a really powerful feature called blocks that enable you to group tasks together and recover from errors experienced in those tasks. And there's 3 parameters that we need to be aware of: the block parameter, the rescue parameter, and the always parameter. The block parameter enables us to group tasks together, and then rescue allows us to recover from any failures in that set of tasks. It's like a try-catch block in a traditional programming language. Sometimes you have a task that should always run, whether there are errors in the block or not, or whether the rescue was successful or not. In that case, you can use the always parameter to specify some tasks that should always be expected to run. So let's see this in action. Again, continuing on with the example of our simple application, let's imagine that we have some kind of authentication configuration file. And what we want to do is enable authentication in that file. If that file doesn't exist, instead of ignoring it like we did with the monitoring config, we want to copy that file into place. And then we always want to run a special command that will clear the authentication cache for our application. So let's see how we can do that. So first I'm going to create a new block. And within that block, I'm going to put the tasks that might potentially fail. In this case, adding that authentication configuration. Much like my previous example, I'm going to use block in file to make sure a block exists in a configuration file. Now again, this time, if that file doesn't exist, if that task fails, I might want to copy that file into place. So now we're going to use the rescue keyword to add some tasks that will copy that configuration file into place. Again, this is like a try-catch block in a programming language. So first, let me create my configuration file. And now with this file in place in the control machine, I'll use Ansible's copy module to copy that file over. Now what we're doing with this block is trying to add our configuration using block in file, and if that fails for some reason, we'll ensure that that basic file is copied over to our managed machine. So let's go ahead and give this a try. You can see that file doesn't currently exist on my web server, and if I go ahead and run my playbook now, what we'll see is that enable authentication task will fail. But once that's failed, you can see that copy base authentication file task was automatically triggered. And now if I look at my web server, I can see that file has been created. Now if I run this playbook again, there should be effectively no changes because the configuration file exists and it has the necessary block in the file. So we saw how the rescue keyword was able to recover from the failed task. What happens if the task was successful? So let me go ahead and delete this block that's managed by Ansible and rerun the playbook. Now in this case, what we'll expect to happen is the authentication configuration task should be successful and that rescue block is never triggered, and that's exactly what happened. Now again, sometimes you'll have something that you always want to run no matter what, and we can do that easily with the always keyword. In this case, let's say I want to run some command that clears the authentication cache on the system, since I've just messed with a configuration file related to authentication. In this case, I'll use the Ansible command module to run a particular command that does this. And again, this command won't exist on your system. This is just a simple example that I'm using for demonstration purposes. So now when I run this playbook, you can see that even though the add authentication configuration didn't make any changes to the system, the clear authentication cache command still ran. Likewise, if I go ahead and delete that authentication configuration file and rerun the playbook, we will see that once again that command always runs because it's set to run no matter what. So let's take a look at what happens when the block or the rescue actually fails entirely. I'm going to edit that authentication configuration file, remove the block that Ansible wants to manage, and then I'm going to make the file immutable. This will prevent Ansible from running to it or copying over it. So this should cause both the block and the rescue section to fail. Now let's try running the playbook. In this case, you can see that both the task related to the block and the rescue failed, but that always task still ran. So it's very important to understand that you can use always in a block to ensure that some tasks always run. And you should consider that when structuring your tasks in your playbooks. There are often some things that you're always going to want to happen on a host. An example I like to use is enabling a monitoring system. It's common to disable monitoring at the beginning of some play, but you always want to ensure that it's re-enabled at the end. So another thing we have to consider at a host level is the running of handlers. Now when tasks in a playbook fail, the handlers section of the play won't run. But there are ways that we can force this to happen. So let's take a look at this in action by adding a handler. So I'm adding a handler here that will restart my application, and now I need to add a task that will call that handler. So I'm going to copy in another configuration here. We'll call it app config. So with this config file created, I'll modify my playbook to copy that configuration into place, and if it's been copied in, I'll notify that handler to restart that application. So now when this task runs and results in a system change, it will notify that restart app handler, and that should restart the application. Let's see what happens. Now you'll see the task to copy the app config file ran successfully and changed the system, but you'll notice that the handler never actually ran in this case, and that's because we had previous task failures here. So we can force the running of handlers using the force handlers parameter at the play level. And this will tell Ansible that even if another task somewhere else in the playbook fails, we still want to run the handlers at the end of that play. And this is very important. It's pretty common that you'll want your handlers to run at the end of a play, whether or not there were some other failures in the playbook. So be sure you're considering this default behavior of Ansible when you structure your playbooks. So let's go ahead and run this playbook again. But first, we have to delete that app config file so that it triggers another change. So now we can see that my application file was copied over, my authentication tasks still failed, but at the end of this playbook that handler still ran. And this is the behavior if you add the force handlers parameter to your playbooks. So at this point, we've seen how we can handle errors and failure at both the task level and at the host level inside of an individual play. Now let's talk about how tasks can have an impact on the play overall, especially when we're running plays with multiple hosts, as we usually are. So let's start by creating a new playbook for this particular activity. And for this task, I'm actually going to grab that task we used previously to check for a manual change disabled file. We'll use that as the basis of our playbook. Now I'm also going to edit my inventory file, and I'm going to uncomment out the other hosts that I have here because we want to see how this performs against multiple hosts under failure scenarios. So I'll start this off by removing all of the files for web server 1 here. And this gets us back to a fresh state on that host. So what we'll do is we'll check for the existence of this manual change disabled file, and then we'll just add one more dummy task to demonstrate what happens when that's successful. So in this case, I have a pretty simple playbook that just restarts our app if manual changes have not been disabled on that server. So let's go ahead and give this a run. And so just as a baseline, we can see that this play was successful across all 4 of our hosts because none of them currently have that change disabled file. So let's go ahead and create that file on one of the hosts and see what happens by default. So I'm going to create that file on web server 1 and then rerun this playbook. So now in this case, what we see happened is that task failed on web server 1, was successful on the other 3 servers, and those servers proceeded to execute the rest of their playbook successfully. Web server 1 did not run the restart app task because the task before it failed. So the play failed for one host, but the others were allowed to continue without any issue. Now there are some circumstances where you might actually want to fail the entire play for all hosts if one particular task fails. So let's imagine that in our environment, if any server has manual changes disabled, we might assume that something is going on in our environment and we don't want to make any further changes. We just want to abort the overall play. We can do that using the any errors fatal parameter at the play level. In this case, if Ansible experiences a task failure on a particular host, it will wait for the other hosts to complete that task and then it will fail the entire play. So let's give this a try. Now in this case, we can see that that task failed again on one web server, but then no additional tasks executed on any of the hosts because we told Ansible to fail that entire play if it encountered any errors. This parameter can be very useful in conservative environments where you really don't want any errors to occur on any of your hosts. But you can imagine that with complex playbooks and in complex environments, you're always going to experience failure. So it can be better to try to deal with that failure using blocks and then use any errors fatal really only as a last resort. So now let's consider another scenario. There are some scenarios where we might want to fail a play only if a certain percentage of hosts experience failures. And we can do that using Ansible's error handling. So using Ansible's max fail percentage and serial parameters, we can specify a maximum failure percentage of a batch of hosts that fail. When that threshold is reached in a batch, then we don't proceed with any additional batches. Let's see this in action. I'm going to define a batch size of 2 hosts at a time for this particular play. Let's just start there, and I'm also going to get rid of the any errors fatal parameter since we're not going to be using that anymore. And let's see what happens by default. Now in this case, we can see that we had 2 batches of hosts. The first with web server 1 and 2 ran, one of the tasks failed on web server 1, and the play proceeded as normal on web server 2. Once that was completed, another batch spun up of web server 3 and 4, and that ran successfully. Now what we can do here is cause the play to fail if a certain percentage of hosts fail. And we do that using the max fail percentage parameter at the play level. Now in this case, it's important to understand, and the Ansible documentation has a note about this, that the percentage must be exceeded, not equal. So if we have 2 hosts and we want to fail if half of them fail, then we actually need to set the percentage to 49%, because if it's equal to 50%, that won't trigger the failure. So if one host in this batch fails, that failure percentage will equal 50, which is greater than 49, which will cause the play to stop and not execute against any additional hosts. So let's go ahead and give that a try. Now in this case, we can see that the task ran and failed on one host. Because that one host was 50% of the hosts in that batch, the play failed immediately and didn't execute any additional tasks on any additional hosts. Now if we increase that batch size to 3, we should see the play complete successfully, and this is because one host is obviously less than 49% in a batch of 3 hosts. And now you can see that the overall play executed to completion. The task still failed on one host, but because the failures didn't exceed that 49% threshold, the play was allowed to continue, and you can see that it executed against another batch of hosts, which in this case only had the single host, web server 4. In a large environment, using batches and the max fail percentage can be a great way to define the tolerance level that your organization has for failure. You're typically going to expect some percentage of failures in a sufficiently large environment, but using this feature of Ansible allows you to set your tolerance for failure. If you're failing too much, then it might be better to abort the entire play and not proceed. So in this video, we've taken a look at 3 crucial elements of handling errors and failure in Ansible. How do we define failure at a task level? What constitutes a failed task? And then what do we do about that failure at the host level? How do we handle the failure? How can we ignore the failure if we don't care about it? How can we rescue from a failure condition? And how can we ensure that certain tasks always run? And then finally, how do we handle failures and errors at the play level? What impact does a task failure have on other hosts in that play? I'd like to leave you with the thought that thinking about errors and failures in your playbooks is extremely important. It's a key element of designing robust automation. You have to deal with failures and errors. You can't just pretend they're not going to happen. Hopefully this video has given you some ideas about how you can do that within your own playbooks. Thanks for joining me on this episode of Beyond the README. If you enjoyed this, be sure to like, subscribe, and share it with your colleagues. I really appreciate it, and I'll see you on the next episode.